Dear students, today we will start with a new subject in the course Introduction to Aeronautical Engineering. My name is Mark Voskel and I will be your lecturer in the field of flight mechanics. Now what you see here is a commercial aircraft flying from Paris in France to London in the UK. It is halfway and cruising at flight level 330, which is at about 10 kilometers altitude or 33,000 feet. Now imagine that this airplane encounters a technical problem and all four engines suddenly stop working. Now this might seem like a hypothetical problem, but it could actually occur when the fuel runs out or when it flies through a cloud of volcanic ash. In 1982, British Airways Flight 9, a Boeing 747, flew through a cloud of volcanic ash above Indonesia, which actually resulted in the failure of all four engines. For our example, there is unfortunately no other option than to start a gliding flight. Now how far do you think this aircraft will be able to glide? A typical commercial aircraft can glide more than 170 kilometers from 10 kilometers altitude. Thus, in this specific scenario, the pilot could actually choose to glide either to London or to Paris safely. Now that is impressive, isn't it? Don't worry if your answer was incorrect. You will soon be able to make these kind of calculations when provided with some basic aircraft data. Now this question is a typical question we encounter in the field of flight mechanics. It demonstrates one of the aircraft performance parameters, how well it can glide. Other key questions I will address in the remaining lectures are, for example, how far can an aircraft fly with a given amount of fuel? Or how long can an aircraft fly time-wise with a given amount of fuel? Or what is the maximum altitude that can be achieved? Or how fast can an aircraft fly? Or how slow can an aircraft fly? Now clearly the answer to these questions depends on many things, amongst which the aerodynamic shape of the aircraft, the type of engine, the aircraft weight, etc. etc. Now once we are able to answer these questions, we can even start working on a very interesting topic, aircraft morphology. If we want a certain performance from an aircraft, then what is actually the optimum shape? So, summarizing, in flight mechanics, the performance of a complete aircraft is analyzed, and the questions I will address are all related to the motion of the aircraft. So this means that all information from the different disciplines have to be integrated. We have to use aerodynamics, structures, or in other words the aircraft weight, the pilot, how does he operate the aircraft, propulsion system, and the atmosphere. And since we are interested in calculating how fast, far, slow, high an aircraft is able to fly, we should start by deriving the general equations of motion. And this is exactly what the next lecture will be about.